doing question 4 on page 98 of section 2.4. It's asking us to find the missing factors by synthetic division. So we're given one factor right here. So we can use that to find the other two factors. If we make this polynomial with a degree of 3 into a polynomial with a degree of 2, then we can find two roots from it using either the quadratic formula or another method. So this root, when you take it out of the bracket, is 1. So we're going to put the 1 right there in our synthetic division. First coefficient is 2, then -7, and 2, and then 3, and there are no spaces, so there's no, if this was gone, you have to add a 0 in here as a placeholder, but because we have a progression of x to the power of 3, x to the power of 2, then x, and then no x, we don't need to add a 0. So we're going to take our first point, move it down, then 2 times 1 is 2, -7 plus 2 is -5, 5, -5 times 1 is -5, 2 plus 1 is 5, is -3, -3 times 1 is -3, which means we have a remainder of 0, which is what we want because we know this is a factor. So now we have a new polynomial of 2x squared. Draw this in a better location. 2x squared minus 5x minus 3. That separates into two roots, which I already know, but we could do the long form, but that would take too long. So we get 2x plus 1 and x minus 3. And these are our two roots, so we can just add them right in here. X minus 3 and 2x plus 1. Okay, so that's one done. Now we're going to look at D, which is a longer question. So for D, we can see that we have a factor of 1, but 3 times, which means it has a multiplicity of 3. So for this, we're going to need to factor out a 1 3 separate times because we have 3 factors that are 1. So digits we have here are 1, -2, 97, -5, and 1. Let's make sure that they're going in a descending order. So we have x to the 4th, -2, x to the 3rd, x to the 2. Okay, so we don't need any zeros. So we can begin with the first one. 1 goes down like that. Then 1 times 1 is 1. -2 plus 1 is -1. -1, 97 plus -1, 96. 96 times 1 is... Oh, I'm sorry. I think that 7 right here is actually a mistake because in my book it doesn't have the 7. Sorry about that. Oh, this is really messed up. Okay. I'm going to redo this question because I just realized the numbers in the book are fairly messed up. Sorry about that. Okay. So, this time with the proper numbers, in the book, the actual equation is this. 2x to the 4. Okay, sorry about that. That's what the book actually says, so we're going to do it from this. So, we've got 2, -7, 9, -5, and 1. Okay, that looks better. Bring the 2 down. 2 times 1 is 2. -7 plus 2 is -5. -5 times 1 is -5. 9 plus -5 gives us 4. 4 times 1 is -5. 4 times 1 is 4. -5 plus 4 is -1. -1 times 1 They give us 0. Okay, so we could write out what the new polynomial would be, but because we want to get, we only need one more factor, we're just going to keep going and do the next step of synthetic division right from here, just because it saves space. So obviously we could write this out as 2x cubed minus 5x squared plus 4x minus 1, and then rewrite out the synthetic division, but there's no reason to do that. So because we have a multiplicity of 3 for this root of 1, we're going to divide by 3, or we're going to use 1 as our factor again. So 2 times 1 is 2. Negative 5 plus 2 is negative 3. So that means that's negative 3. 4 plus negative 3 is negative 1. 4 plus negative 3 is actually positive 1. Sorry about that. Positive 1. So then this equals 1 and this is 0. So again, we can see that 1 works as a factor. Now because we need one more, because we only need to find one root, and if we try to do it from this, we'd be able to find 2, which we don't need. So we can just simplify this and go one step further. 2 times 1 is 2, negative 3 plus 2 is negative 1, negative 1 times 1 is negative 1, negative 0, so we are left with 2x minus 1 as our final polynomial. And we didn't even have to do any factoring from a quadratic, so that was kind of nice. So we're left with 2x minus 1. We'll do one more practice. We're going to be doing C. Okay, so C, we have, let's see. Okay, so we have 1, 1, negative 9, negative 9. Those are our points. And yeah, okay, perfect. So our factor that we know is negative 1 when we take that out of the bracket. So we can just do a synthetic division. 1 times negative 1 is negative 1. Is that equals 0? 0 times negative 1 is 0. Negative 9 plus 0, obviously negative 9. Negative 9 plus negative 1 is positive 9, so that equals 0. So we're left with a new polynomial of x squared minus 9, and this is the difference in squares, which means our two roots are x plus 3 and x minus 3. So there we go. That's how to find missing factors using synthetic division. So yeah, just take the factor, use it as your factor for synthetic division, put your points, and if you have a multiplicity of more than 1, you can synthetically divide more than one time to get to a polynomial of 2x minus 1 instead of something much bigger. For example, x squared minus 9. It's a lot nicer to just be able to work with an x instead of an x squared. So that's why we use this 3 times instead of once. Alright. Thanks for listening.